With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us try to solve the given problem. So the given problem simply states shape of interference fringes formed on the screen due to the point source P in case shown here will be, and we have four options: parabolic, elliptical, circular and hyperbolic. Now you can see we have a point source here and we have a plane mirror here, right? And the screen is placed at a distance y. Now it is saying that if this point source forms fringes on this screen, then what will be the shape of those fringes? Will they be parabolic, elliptical, circular or hyperbolic? Now we know that in Young's double slit experiment, there are two slits. That means there are two coherent sources. But here you can see that there is a single source. So now first let us try to understand that how a single source can produce fringes on this screen. So first let us try to understand that. Now you can see here what will happen is that this single point source image will be formed inside the mirror at somewhere here, right? So this is point P and let us say its image P dash will be formed here. Now this image P dash will simply act as another independent light source and the lights from 2 will fall from the screen. Let us take at any point here. Let us take any point Q here. So you can see here that the light ray from this point P and this point P dash will interfere at this point on the screen. Now this P dash is simply nothing but it is a reflection of this point P. Remember this, that it is a reflection. So what actually happens is that when light falls on this mirror, it goes to this screen and light also directly goes to this screen. So there is some part difference. So when light goes from this mirror to screen, we are assuming that the light which is the reflected light which is reaching here is simply reaching from this image. That is the assumption. So you can see that if this is the distance x, then definitely this will also be x, because we know that for a plane mirror the image is as far behind the mirror as the object is in front of it. Now let us try to solve this problem, but before that let us draw a simple diagram for better understanding. So you can see here, I have completed the diagram. I have taken the origin at this mirror. So this image will be simply at minus x comma 0, right? So this distance will be simply minus x comma 0 because the point source is at x comma 0. Now I have assumed that q be any point on this screen and we will find the path difference between these 2 points. Let us take that at this screen any point is simply at h comma k. And now why we have taken h comma k? Because we have already taken this to be x and y. So let us take these 2 points as h comma k and let us now try to find out the locus of this point q. Now the locus of this point q will simply give us the shape of the fringes. Let us now try to find out. So from here you can see that this is p dash q. P dash q, what is the value of p dash q? Value of p dash q is simply square root h plus x. We will apply the distance formula whole square plus k minus 0 whole square. So this is p dash q. Now similarly we can find p q. This will be square root times h minus x whole square plus k square. Now how do you find the part difference between these two rays? So the part difference is simply written by part difference. What will be the part difference between these two rays? Very clearly we can see that. Let us denote the part difference by del. So the del will be simply equals to p dash q minus pq, right? So we will call it delta. Delta is the part difference. Delta is equals to p dash q minus pq. Now let us bring pq here. So this will be delta plus pq. This will be simply equals to p dash q. Let us now put the values square and let us now put the values and square the terms. And putting values and squaring, let us see what we obtain. Putting values and squaring both sides. Let us see what we obtain. So you can see here, I have done some calculations here. So we have to put the values of PQ and PQ dash and we have to square both sides. So you can see that this will be delta plus PQ whole square is equals to P dash 2 square. Now if we open the square here, this will be delta square PQ square plus 2 times delta PQ. This will be equals to P dash Q square. Now, what I have done, I have substituted the value of PQ. Now you can see here what is the value of PQ. PQ is simply h minus x square plus k square root. So I have substituted the value here. So you can see here the square root will simply cancel out. This will be h minus x whole square plus k square plus this term is as it is written 2 times delta the value of PQ is square root h minus x whole square plus k square. Now in place of P dash Q whole square we have written the value of PQ. Now we have opened these square also. So you can see that I have opened this square. This will be h square plus x square minus 2hx and this will be h square plus x square plus 2hx. So I have cancelled the common terms from here and what I have written, I have rearranged this equation. This will be like this. Now once again, to find the locus of the point in terms of h and k, remember that if we find the locus in terms of h and k, then we will know the shape of the fringes. So we have rearranged these terms and again we are squaring both sides and then we will be solving. Let us see what we are going to get. So you can see here I have substituted the values again. Now I have substituted. Now we have to square on both sides and then we have to solve. So I have squared this side and I have squared this side to reduce this square root. Now you can see that the square of this will be simply lambda to the power 4. The square of this will be lambda to the power 4. The square of this will be 16 h square x square minus 2 times a into b. So this will be 8 hx delta square. Now similarly here this will be 4 delta square and this term the square root will cancel. So this will be 4 delta square will multiply to both these terms. So this will be 4 delta square h minus x square plus 4 delta square k square. Now I have opened this square also. So you can see that I have opened this square also. So you will see here this will be 4 delta square h square plus 4 delta square x square minus 8 delta square hx. Now here is also 8 hx delta square and here it is 8 hx delta square. So they will cancel out and I have rearranged the term like this. Now you can see here that this is a constant. Now since x was a constant because the distance, you can see here this x is a constant distance of this point source, right? So x is a constant and here h and k are variables. So if we have rearranged this equation in this form, so it looks something like this. This is h square into this term plus 4 del square k square simply equals to this square. So these terms are simply constant and this will reduce to equation like this. This is h square plus k square equals to r square, which is simply equation of a circle. Which is simply equation of a circle. So the fringes form due to this type of arrangement. When a point source is placed in front of a mirror, then the circular fringes will be obtained on this screen. So this will be the correct option. I hope you understood the entire explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.